Hi, I'm Brian from Simply Brian Enterprises and welcome to my channel. In today's video, we're going to be looking at the homework solution for TopTechBoy's Raspberry Pi Pico class, lesson number 4. In last week's lesson, we built a binary counter using an array of LEDs, and this week we're going to take that a step further and just do some other things with an array of LEDs and have a little fun with it. As usual, I'm going to take a look at the hardware, run the program, and then take a look at the code. So as far as the hardware goes, pretty much the same setup as last week. I've got my 5 bits. The only difference is I changed from green to red. And the reason is because this week we've built a Larson scanner or a Knight Rider light thing. I don't know what that's called in the Knight Rider world. Drop a comment below. I forget what that's called. I know the car was Kit. I don't remember what the actual effect was called, but we'll call it a Larson scanner for lack of a better term. And so we just run the program and you see we're just going from right to left, left to right, back and forth, back and forth. And let's take a look at the code. And really I took a lot of the same code as last week and I just made a couple of modifications. So let me pop back to the hardware view here for a second. So I've got these 5 individual bits and I only want to light the highest bit. So instead of counting up 1, 2, 3, and then lighting both of these bits, I just want to count 1, 2, 4, 8, 16. So if we think about the progression from 1 to 16, we see that that's not linear, it's exponential. We're actually doubling the value every time. So that would suggest that we'd want to use maybe 2 to the power of the bit. So um, so here we have 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16. So we can use kind of our same counting. We're just instead of moving linearly through the numbers, we're going to move exponentially. So as we look at the code, what we see is that, again, this is pretty much the same code as last week. I changed the delay because I want it to move faster left to right. I'm clearing the pin values. And this time, instead of doing a while true, because true is always true, I want the code to end. I don't want it to run back and forth forever. So I've set, instead of while true, I've set a counter. So I first have to clear the counter, set it to 0, and then I'm going to say 30 passes, so left, right, left, right, left, right, 30 times, and then we're going to end the program. So when I start the first progression from right to left, I'm going to count from 0 to 5 because, or in this case 0 to 4 because range always clips off the last one, because I want to go 2 to the 0 to 2 to the 4th. My bin val, last time I just copied this counter value into bin val. This time I'm going to take 2 and then to raise to an exponent, it's star star in Python. So I'm going to take 2 raised to the bin val. So 2 to the 0 through 2 to the 4th. And then I'm just going to go through exactly the same code. I'm just going to strip off the binary and say, okay, is it 16? Okay, subtract 16. Now the answer is always going to be 0. 8, subtract 8, it's always 0. So we can just leave that code the same. Now when we come to the other direction, you remember last week I counted up and then counted down. We have to do a little bit of thinking here because if I just do the same in reverse, if I go 0 through 4 and then I say 4 through 0, well, what happens is we end up stopping on the ends because we basically write to that pin twice and we pause to that pin twice. So I'll write a nice smooth 0, 1, 2, 3, 4, but then I'll write 4 again. We'll stop here, 3, 2, 1, 0, write 0 again, stop here, and we don't get that nice bouncing effect because when we run the program, here I'll run it real quick, you can see we have that nice bounce right off the end of it. It's not stopping, it hits the end and it just bounces right back. And we want that. So what we have to do is we have to change the value of the return path. So on the forward path, it's 0 through 4. But then we don't want to light 4 on the return. We're just going to do 3, 2, 1, And then we're not going to light 0 because we're going to loop back up to the top and we're going to light 0 on that loop. So that's why we're doing here, the range is only from 3 to 0, which means 3, 2, 1, and stop. And again, I'm doing the negative step this time. So I'm doing 3, 2, 1, stop, loop around. Then the first write in the previous segment is 0, 1, 2, 3, 4, 3, 2, 1, loop back around to write 0 again. And then as we go through that, same the same value, same math is used to write out the value. Um, then what I'm going to do is when I get through the right to left, left to right, I'm going to increment that counter by 1 because I'm only going to go through this loop 30 times. And so it's going to go through, increment the counter, loop, 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 and then once it's run out of loops, then it's going to clear the pins. So that way all the LEDs go off after it finishes the program. So I hope that was kind of neat seeing a Larson scanner, but I thought, we were challenged to do some other things in lesson 4 as well, and I thought of something else I wanted to do, but before I do it, I need to make a quick hardware change. So I'm going to pause the video right now, and when you come back, the board's going to look a little different, and then we're going to run some more code. And just like that, I'm back. So let's take a look at the hardware change I made here. I traded out my all red LEDs for red and yellow because I want to do a little bit of an effect here. So I'm going to run this code and you're going to see what we're doing. So first of all, just a bunch of blinking LEDs doesn't look interesting. But what if I put something over that? What if I put a diffuser over that? And you can see I have made an electronic candle. I've made a software-based candle that flickers, and the fun thing about doing a software-based candle is we can do other things, not just flicker. We can actually kind of mess with people when we write software for candles. So let's see if this does something maybe a little unexpected while we're watching. Hey, did you catch that? The candle had a message for us. If you caught the Morse code message, be sure to drop a comment below. Thought we'd have a little fun going back to the Morse code world. So let's take a look at the code and see how we did that. So this code is actually partially adopted from some old Arduino code that I wrote several years ago. And trying to move it into the Pico world, I decided to do things a little bit differently, at least to start off with. We might revisit this project later as we learn some more techniques and make things a little easier in Python. But for now, we can have some fun with it. So I come through here. I've added a function which is the random integer function. We haven't learned that yet, but that's an important function when we're doing things like this. And we can see I'm just setting up my GPIO pins. I'm setting up my Morse code timings again using 13 words a minute. And so let's talk about how I make the flame. So in the Arduino world, what I would do is I would wire up 5 LEDs to PWM pins, and then I would take a random value between 0 and 150 and then add 135 to it. So that gave us a functional duty cycle of between 135 and 285, and that's on a range of 0 to 1023. So maximum brightness was about a quarter duty cycle or 25% duty cycle between, I think, like 15 and 25% duty cycle. And then I would write down each pass through the loop. I would write down the duty cycle of each LED, light it, and then I would pause for some random value between 0 and 100. Sometimes it would go quickly, sometimes it would be short, or I'm sorry, sometimes it would be short, sometimes it'd be a little longer, but it gave a more natural flicker. I'm not using PWM this time around, so I have to do it digitally. And we haven't talked about PWM in Pico class yet, but basically what we're doing is we're taking a digital signal. So we're taking a 1, come over, down for a 0, over, 1, over, 0, over. And by adjusting the width of that 1 and that 0, we can make the LED go brighter or dimmer. And so what I'm doing here is I'm kind of simulating a PWM signal. So I've got, obviously my candle is running in a loop, but there's actually two loops. There's a loop, there's the whole program loop, and then there's a loop to do just the flickering. And at some point we want to break out of the flickering to get to the Morse code. So what we're going to do here to make the flicker, every single LED, every time through the loop, I'm picking a random number, 0 or 1. So the LED is either lit or it's not. So I'm setting up all 5 of them. Then I'm figuring out my delay time. How long am I going to stay in that state? And because I'm not using PWM, I have to kind of fake it a little bit. So I'm using a very short timer. I'm going from 0 to 8 milliseconds. So the maximum time those LEDs will be lit in that state is 8 milliseconds. And you can kind of see, it's a little tough to see on the camera, they're flickering very quickly because they're only staying in that state for a handful of milliseconds. Then because it's Python, I have to convert it from milliseconds to seconds by dividing by 1,000 and then sending that to the sleep directive or the sleep function. And then I'm going to increment the counter. Just like you saw in the Larson scanner, I only want this to run so many times. So I had to do a little math to think about what is that counter value. If I want it to flicker for about 30 seconds and then go into the Morse code sequence, how many times through the loop is 30 seconds when everything is random? And so we have to just kind of take the average. We have to say, okay, well, if my delay is between 0 and 8 milliseconds, over several runs, it's going to average out to somewhere around 4 milliseconds. So we can say that 4 milliseconds, we're going to run through this loop 250 times a second approximately. So then I can just take 250 times 30, come up with 7,500. Now, if I were to put a stopwatch on this, I can guarantee it's not going to be 30 seconds. It's going to be a little less or a little more. But considering we're running this loop so many times, and because of the law of averages, we're probably going to be pretty close to 30 seconds. So then we've come out of this loop. We've hit our 7,500 or our 30 seconds of flickering. And the first thing I'm going to do is I'm going to reset the counter, because when I'm done with my Morse code, I'm going to come back up to the top and I want this all to run again. So before I forget, I'm going to reset the counter. Then I'm going to send my my AA, my all after, meaning, hey, I've got a message coming for you. And this time I have to flicker all 5 LEDs, which is a bit of a trick and made for some lengthy code. But basically, this is just the same as we saw in lesson 2. All 5 LEDs on, we sleep for a dit. All 5 LEDs off, sleep for a relax. All the LEDs on, sleep for a da. All the LEDs off, sleep for a letter space. So we did the A. Now we're going to do another A, and then we're going to do a word space and an A and an A. And we just go down, 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 down like that all the way through. So we do 2 sets of dit da. And then we have to stop looking at the code, because no, you cannot see what happens next. You've got to tell me down in the comments below, what is the message? And you've seen it blinking this whole time while I've been talking. So you have no excuse. You should be able to figure it out. All right, so I hope you enjoyed that kind of silliness, but fun anyway. And lesson 4 was really kind of, let's be silly, let's be fun, let's think outside the box a little bit. But now I want to show you something really quickly that maybe you missed, and this is where it gets really exciting, especially for those of you who are kind of new to this hobby, new to these ideas. We're going to do something kind of fun here. So I'm going to go back to, oh, give me a second here. I got too many mice. Hold on. Run this real quick. All right. Now I'm going to head back to the hardware. So this is the hardware setup. We're just going to leave it as is, yellow, red, yellow, red, yellow. And I'm going to come in here and I'm going to go back to some of our previous programs. So here's lesson 2. Here's our Morse code program. Can I still run this? And yeah, just like that. My Morse code program from lesson 2 still runs. What about our lesson 3 program? What about my binary counter? Does that still run? Oh yeah, my binary counter still runs. What about the Larson scanner that I demonstrated at the beginning of this video? Does this still run? Hey, look at that. Different colors, obviously, but it still runs. And the reason I want to point this out, is because without making any hardware changes, I just ran a handful of programs that did very different things from each other. One just blinked Morse code on one LED, one counted in binary, one did a Larson scanner, and the other did a flaming candle with a Morse code message without making any changes to the hardware. This is where it gets exciting when playing with the Pico or the Pi and Python. We can take one set piece of hardware and without making any changes to the hardware whatsoever, everything in the software, we can make it do radically different things. When we start doing things like adding push buttons and potentiometers and buzzers, think of just how many things you can build, you can design, you can think of without making any changes to the hardware. I just set up a button, I set up a potentiometer, I set up a buzzer, and how many different kinds of programs can I run that look nothing like each other using the same hardware? That's when this gets really exciting, and I'm looking forward to those lessons in the future. If you like this video, be sure to hit like and subscribe below. Thank you to all my new subscribers. I appreciate you. And I look forward to seeing you next time. For Simply Brian Enterprises, this is Brian, and thank you for watching.